Hey, hello students. So today's class we'll continue where we left off in the previous, that is principal stresses. I think we defined clearly what principal stresses are. The principal stresses just means that at any instance there will be no only principal stresses, that is maximum stresses are acting on a certain plane. Okay, I also gave an example of uh, a plate with not a plate, it's a cylindrical shaft which is subjected to both bending and torsion. Whenever you encounter physical problems such as this, you you apply this rule of the principal stress and extract the maximum stresses. So you need to decide on material, right? So particular material um, needs to be decided. So in order to come to a conclusion, this is the assumption which we are making, that is with respect to the principal stress. So continuing with that, there are several ways in which you can find the principal stress. So one such way is the Morse circle. So Morse circle, I think you are familiar with in from MOS, right? So if you have a biaxial stress system with shear like this, as you can see in figure 1, you can represent this stresses whichever is shown, so sigma x, sigma y, and tau xy. Okay, keeping sigma x value from the origin. So let's say x-axis is your stress and y-axis is your strain. So keeping sigma x, okay, as your uh, point here, that is median. Okay, you can easily draw this Morse circle using the given data, that is principal stresses here. Okay, so that's how you would do it. So using the angle too, that is theta would be given either here or here. Theta would be given. So use that angle as 2 theta. Okay, and finding the stresses, that is sigma 1 and sigma 2. Okay, so these two, sigma 1 and sigma 2, are nothing but our principal stresses. Right. So this is the easiest way to find the principal stresses which are acting on a biaxial stress system along with the shear. Right. So these equations already have done it before. So you just differentiate this equation we have defined for a biaxial stress rate with shear. And if you differentiate this with respect to theta and equate to 0, you will get two different equations. So that's how you get the principal stresses, the value for principal stresses, right? And also this is how you get the shear stresses, values for shear stress. Again, you have the uh, shear, shear stress in biaxial stress system with shear, and again integrating that with respect to theta and equating it to 0, you'll get this equation, right? So that's a shear in principle, shear stress. Now let's start off with a numerical problem here. Um, so this is the first question. Let's say in this question we have so we'll be using the equations which we derived so far. So we have a rectangular bar of cross section 50 mm by 25 mm and is subjected to tensile load of 25 kilonewton. So determine the value of normal stress and shear stress on the plane at 30 degrees with the vertical. So also find the magnitude and direction on which the shear stress is acting. Right. So let's try to draw this. Okay. I think we can finish it off here. So this is a rectangular bar. It's not that flexible. Let me do it in another app. Okay, so check this out. This is the first problem. So you have a rectangular bar with 50 mm by 25 mm. Right? So assume this to be a rectangular bar. It's subjected to tensile load as given in the question. You are subjecting it to a tensile load on either side. So this load, let me say it is P, value 25 kilonewton. Okay. So dimensions 50 mm by 25 mm, and you need to determine. Let's go back to the question. So you need to determine the value of normal stress and shear stress on the plane at 30 degrees. Right, 30 degrees. The angle is given. So yeah, the 30-degree angle is given. So we can use that, and let's say the question is clearly asking us to find what is happening at an angle of theta, that is 30 degrees. So at this point he is asking what is the normal stress and shear stress. So let's say this is the normal stress, that's called sigma theta, and shear stress is tau theta. What are these two values? That's the question here. So that's the pink part. So yellow, whatever is given is a question. Okay, let's go back to question once again. 30-degree vertical. Also find magnitude and direction of maximum stress. Okay, so cross-sectional area we can find easily. So let's write down data. So data is you have area A, which is 25 times 50. That's coming to 1250 mm squared, and you have load. So you can call it P or even F or whatever. All mean the same. F also is a force, or you can call it P, capital P. That will be 25 kilonewton. That is 1, 2, 3 zeros, and you have kilo, not kilonewton. This is just Newton. You expanded that kilo, right? So now, how would you come about the equation? First, let's find the normal stress. That is, this is the load here which is acting. If you were to find the normal stress, that is sigma x in this direction, what is the stress along the x direction? So if you analyze, this is your x and this is your y, right? So what I was going this way, we'll take it as positive. Okay, so stress is going this way, so let's take it as positive, and sigma x. So this is the solution part. So sigma x is just load over area. So both of which we have it here, indirectly substitute. So you have 1250 divided by 25 into 100, or let's write up 2, 3. So keep your calculators handy. Okay, keep your calculators, and you can solve it and post it in the group chat whenever you're solving. Also, I wanted to share one more thing. Do you have the data handbooks with you? Did Guru sir share data handbooks? Yes, no, anything?
No, sir, not yet.
You have the data handbooks? No. Okay,
No, sir.
fine, fine. I'll share it in the group now. I forgot to give you guys. I thought Guru sir would have given by now. Fine, I'll share it to you now.